Good morning, everyone. Please do apologize. We are still waiting for Mr. Bodo to join. It seems like he has a difficulty in joining this Zoom. Hi, Mr. Bodo. Finally,
Yeah, I'm sorry.
would you please state your...
Well, I tried using the QR code. It might
I
be an idea to also include a web link next time. So because the QR code led me to a web link that then said, do you want to start the meeting? And that's not my job. BMKG Indonesia start the meeting. Anyway, when I eventually clicked on it, then it got me through to the registration process. So maybe I was too cautious. Anyway, here I am.
Nice. Thank you for letting us know about this. So, okay, so good morning, good afternoon, everyone. Perhaps some of you also good evening, maybe. So, first of all, thank you very much for joining our 7 regional focus group meeting of Indonesian Virtual Laboratory Center of Excellence, which is conducted in collaboration with the Australian Bureau of Meteorology this time. We have, as announced, that today focus will be the utilization of satellite data for air quality analysis, and we already have 2 experts. The first one is Dr. Alberth Nahas, and the second one is Mr. Bodo Zeschke from the BOM. Dr. Alberth Nahas, he will talk about exploring Earth observation data, wildfires, and air quality analysis. And then Bodo will also talk about a memorable Easter Sunday, investigating the Melbourne Haze event on 31st March 2024. So, for uh, for this regional focus group meeting, I will invite first Mr. Alberth, Dr. Alberth, to give the presentation for 20 minutes, and then Mr. Bodo to give the presentation another 20 minutes maximum. And after that, we will use the rest of the time for discussions. Before I invite Dr. Alberth, I would like to inform you all about his short CV. So Alberth is an air quality and climate analyst at the Indonesian Agency for Meteorology, Climatology, and Geophysics, or BMKG. He holds a PhD in atmospheric science from NC State University, Raleigh, NC. His research interests include atmospheric chemistry, air quality, geochemistry, and climate. So without further ado, I would like to invite Dr. Alberth to present your topic. Time is yours, please.
All right. Thank you, Bu Ani. Good day, everybody. Let me start my stopwatch first. Got 20 minutes. Hopefully, I will not use all the time for the presentation, so we will have more time for the discussions afterwards. Okay, I'm going to share my screen. Hopefully, you can all see this my screen right now. Okay.
Kita.
Right. As mentioned before, we discussed about exploring Earth observation data. We will use two use cases later on, wildfires and air quality analysis using satellite information. My name is Alberth Nahas. I am with the BMKG for the Directorate for Applied Climate Service at BMKG. Nice to meet you all virtually today. It's morning in Jakarta. Hopefully you have a wonderful day wherever you are. Following this discussion today, the outline of my presentation is more like a sharing session. Actually, is like this. We will set the scenes of what we will discuss for today's meeting. We will need some background information of why we need satellite information for our analysis. Where can we get the data from, and how does a satellite detect air pollution, whether it's accurate or whether it is representations of the real world or real case, and are the results comparable to the ground measurements? Because of course the ground standard, the gold standard for the measurements, obviously the ground measurements. So if we can compare the results, or we can use the satellite information and the results are comparable, then we can use the satellite information as the proxy. Some of the satellites we can use, and I will introduce some of them when we talk about the use cases at the end of the presentation. Right. Why do we need satellite information? In the context of air quality monitoring, you can see here the image. Let me check. The image on the left, it's the ground sensor networks, and you can see that the number of sensors is very limited. There are some locations that are not covered by ground sensors, so we need another approach to capture all the spatial distributions and spatial patterns of air quality. That's why we use satellite, because satellite has the capability to capture or to take images from almost all locations, if not all locations. If you combine different satellite information, then you can get a full picture of the spatial distributions of any particular air pollutions. Of course, the advantages for the satellite area of information are the area coverage. It can cover more areas, even the locations that don't have ground measurements. But of course, there are some operational challenges that faced by both approaches. But in terms of satellite, usually it will take years before we take down the satellite from its orbit, and we can use the information for quite some times. And usually there are some missions that are the replacements of the previous missions, so we can guarantee the data consistency throughout the years, and that is the practice of satellite information. Of course, we have other options for air quality data, or any data in general. Ground-based measurements are the gold standard, but we have challenges in terms of the spatial distributions and then also the operational costs of this. And then we will tackle on satellite information later on. Other than that, we have aircraft missions. They take measurements during the path of the flight, and they collect the information, whether it is air pollution or meteorology along the way when they take the path or take the flight. And of course, we have numerical modeling as sometimes a complementary, sometimes is blended into the other types of the data and information. And how does a satellite detect air pollution? So you have to remember that satellite does not measure air pollution directly, but measures spectral radiances, or it needs to generate an algorithm to convert from spectral radiances to air pollution or any air quality parameters or any parameters of, in that context. So it's very important when we use satellite data, we have to verify the data with ground measurements so that our results are compatible. And it brings us to this one. We will use one of the products that we will use for today's meeting is from Sentinel, and one of the products of Sentinel is aerosol optical depth, or AOD. And here is the comparisons between satellite derived information and the data collected from the ground-based measurement. As you can see here, the ground-based, it only measured the concentrations, or in this example is aerosol optical depth for that location. It doesn't move. And it stays, it's fixed. So it only collects the information from that particular location. But for satellite, as you can see here, well, you cannot see that it actually moves. There is an orbit that it follows. It can be geostationary or polar orbiting, depending on the types of satellite. But it covers more area, and the swath of the satellite can provide information on different regions, but they are not actually comparable. You can see from the previous slide that the satellite doesn't measure air quality parameters directly. Rather, it measures the spectral radiance that then converted into concentrations or total column. And another difference is the satellite measurement usually measures the total column, so it doesn't measure the level of or the concentrations of the air pollutant on the surface. It rather measures the vertical integrated column of the air pollutants, because the satellite usually is high above the space, and as it moves, it measures the total column from the surface to the level of the satellite orbiting the Earth. And here are some examples of the satellite. These are the satellites that collect air quality data. We will use some of them for our use cases later on. Most of all of the data from the satellite, particularly the data that are related to air quality, are free to use. So you can download the data. There you have to create an account, and it's free. And once you have the account ready, then you can download the data from the website. And I will show you later on how to access the data, because we will use the data for the use case. All right, so we have two use cases for today's meeting. The first one is the 2025 California wildfires. I choose this use case because it's recent. I think most of you have seen the epic images of Hollywood Hill being burned. I don't know if that's true or it's an AI generated image, but you have the idea that it was a major concern in the state of California. There was a influence from dry climate and Santa Ana winds. Which is very typical for the dry condition in the region. The event saw several major wildfires, causing widespread damage and, of course, air pollution. It was also a life-threatening event. There are casualties and loss due to the fires and due to the air pollution. And for now, for this meeting, we can use the satellite information to sort of, it's not really for early detection, it's rather for analysis, but you can also use this for early detection if you have the event occurring at present. And the satellite data can also provide us with a better understanding on fire behavior, and we can improve our response times and also informing mitigation strategies. And this is something that is difficult to get from the ground-based measurements, because for ground-based measurements you have to have densely populated sensors in the region or in the region of interest, and then you can provide the information to most of the, or if not all of the communities within the region. For satellite, you can use that because it covers the whole spatial and location. So I will switch to the use case later on, but these are the steps that we will use to get the results from the satellite information. We will use hotspot data for 2025. We use the data for January 2025 for California, and then as the output of the product is the burned area estimates, and we can also compare the results with the actual data. The second use case is the NO2 time series analysis. NO2 is a key air pollutant. It usually comes from vehicle emissions and industrial activities, so it's a perfect species that we can use to represent the anthropogenic activity. We will use the Sentinel-5P satellite from European Space Agency to get the data, the atmospheric NO2 total column data. And we will pick some cities in the Asia Pacific region and see the results. And here are the steps to generate that. Okay, I'll provide the link here. I think the organizer will share the PowerPoint later, so you can have the PowerPoint or the PDF, and then there are two links that you can click, and it will lead you to the hands-on practice, which we will see about now. Okay, I use a Google Colab platform, so you don't have to install anything. If you use Windows or Linux or any operating system, you can use it as long as you have the internet connection and a Google account, and you can access this. And I believe the content is sort of self-explanatory. It's very detailed. I try to put information, a lot of information there, so you can get the idea what is going on with the scripts and with the process, and we can get the data or the results from this. Each of the we call it notebook. Each of the notebooks will have this section, and there are some sections that will take some time. So I already done that in the interest of time. So for this one, this is California wildfires. I already download the data. That this is the hotspot data for January 2025, and this is actually for the global hotspot data. Here, if you're not familiar with Google Colab, one thing that you need is just to click this button, this run button, and it will do the trick. You can get the results, and this is already done. The data is already downloaded to this virtual machine. By the way, you can also connect your Google Colab with your own Google Drive if that is your preference. So I have this a script for you to connect your Google Colab to your Google Drive, so you can upload your data there, and you can work from your own Google Drive. But for this one, I use this virtual machine provided by Google Clouds. So I already downloaded data. I just have to continue with other processes, and each of the steps will have some kind of process, and also once it's done, you see the tick, the green tick mark here. It says that it's done. The step B is done. We can continue with step C, which is the processing. Again, you just have to click it. You can get all the information about the code here, what it's written, and why you need to do it. Why you need this section, for example. And what I will want to show is just the result, some of the results that we can get from here. So basically what I did for this notebook is first to map the daily time series of hotspots in California, and you can get the data here, all the daily number of hotspots. So I think this is the beginning of the event, January 7th, and you can see that.
Yes, you have like less than 5 minutes to go.
Yep. Yep.
Okay.
Yeah, almost done. And then this is the map of the hotspots. And from these hotspots, you can actually estimate the area, the burn area. Again, using this script. And the last thing you will do is to generate the image. Okay, it will process everything. And once it's done, we can generate the image. And while we are waiting, we can go through the second use case. I also have done the first step, which is downloading the data, because it will take some time to download the data from the satellite. Once we have the data, we load the data, we can start with the visualization. Should be very quick. And this is the example. So this is the example of the results. This is the daily NO2 levels in 2024 for the 6 series. Yeah, you can see the daily trend here, and the seasonal trend. Oh, by the way, we can look at the seasonal trend later. So this is the daily time series. And then if we want to compare the weekday versus weekend NO2 levels, we can also do that. We just have to click this, and it will generate the image, and just a short information that we can get from here, that usually the weekday NO2 levels are higher than weekend, because the vehicle load during the weekday usually higher than during the weekend, and that is seen. You can see from all the city here. And last thing is the seasonal comparison. course, usually the highest CO2 levels are during winter time, winter and fall, and it is shown here for most of the cities, with the exceptions of Jakarta and Manila, because these two cities don't have really winter or fall. Okay, I think that's all, and this is the results. And there are some explanation. You can follow the explanation here, the information, and if you have any trouble, and you have my email, it's written here in almost all my slides. So that's it. Thank you for your attention. Now I return the stage to Bu Ani. Thank you so much.
Thank you so much, Dr. Albert, for sharing this important information. So later on, we will discuss if you have any question. But I already seen some questions in the chat. So while waiting for this question session, maybe Albert, could you also please perhaps try to answer by typing in the chat. So I would like to invite the next speaker, Mr. Bodo. So, but before that, even I understand that you might be already known about him, but I still need to introduce him to you. Perhaps some of you maybe not known him. So Bodo is a lecturer at the Australian Bureau for Meteorology Training Center since 2009. The main topic of his teaching include tropical meteorology and satellite meteorology, and he obtained his degrees qualification in Australia in physics and meteorology, and focusing in satellite meteorology applied to tropical cloud coherences, and he has been working in the BOM Australia since 2000s, and he also has experience as the weather forecasters in Tropical Cyclone Warning Center Darwin for 8 years. So Bodo, without further ado, I would like to invite you to present your presentation. But before that, I would like to say hello to all the participants. I saw many participants from all over Indonesia, from east to west, and also I also see some colleagues from GMA, BOM, Maldives, Timor-Leste, Hong Kong observation, Met Malaysia, and also TMD. So, okay, Bodo, time is yours now.
All right, thank you very much for that, Ani. I'll just share my screen. So there we go. Can you all see my first slide here?
Yes, now we can see that. Perfect.
Okay, so I'd like to, as Ani mentioned already, I'd like to, I guess, focus on a particular event, a very memorable Easter Sunday, and it was actually the Melbourne Haze event of the 31st of March 2024. And so what I'll be dealing with is really some initial observations, and they occurred whilst I was going for a walk. It was my Easter Sunday. Didn't have to do any work, and so I went down to our beautiful St Kilda beach and later on to the Melbourne City Gardens, and it had really strong impressions about this day, and it was brought about by the haze, by the smoke haze that was over the city. Very surprising. I will then go on to look at the further investigations over the local Melbourne area, but looking at satellite data, so Himawari and some polar orbiting satellite data, linking it in to soundings, visibility, and ceilometer observations, and with some word from impact on aviation observations. And finally, looking at what Dr. Nahas already mentioned, the aerosol optical thickness, aerosol type, also using the NASA Worldview website, and also a final point on the importance of PM 2.5 and its impacts. I should say too that I've had this material has actually been looked at by one of our fire and air quality forecasters at the Bureau of Meteorology. So feel confident in presenting it. Let's start with my observations during that Easter Sunday walk, and it started on St Kilda Beach. You can see that down the bottom there. And gradually, I made my way back into the city, past some of our big skyscrapers. This is the Eureka Tower. And then on to the gardens, the Fitzroy Gardens, and you can see that there. And so looking at all that and just sort of analyzing it from a point of view of, well, I guess the impression it makes, but also a little of the bringing it into the focus of our talk today, there was a milky, hazy sky. It was almost like the sky was glowing. It had an incredible impression on me, actually. The whole sky was lit up. You had light rays emanating from the windows of these high rises. And in the parks, you had little pockets of incandescent glowing atmosphere. As a child, I would sort of see something magical, almost sort of fairy-like in that. It made a very, very strong impression. Now, the thing was, of course, we also have a webcam that I was able to, of that day, from one of the skyscraper high-rises in the Melbourne CBD looking down. And this is from the South Bank, just south of the Yarra River. So what you can see, the three at the top are the morning pictures, and the three down the bottom are afternoon going into evening. And so you should be able to see that there was low cloud early in the morning, but then there was haze below that. And then as we go into the afternoon, again, haze. And it was actually this scattering of the light in the form of this white, making it appear this magical glowing or a whitish color. It's actually me scattering. And we'll get on to that shortly. But just to put it a little bit more on another level, I actually forwarded some similar diagrams of similar kind of appearance of these, for example, these rays coming off the high rises to Facebook. And it's really the scattering of light from dust, smoke, and haze particles. That's known as me scattering. And you can see that this particular Facebook post from the Bureau, I was forwarded the images and basically got that posted. I felt really pleased about that. That's got 560 love hearts. So that was really, really nice, very memorable. And it really lined up with my amazing Easter Sunday experience, just walking amongst the sky, just lit up beautifully because of smoke haze, as you'll find out. But just to anchor it down a little bit into the science, what we have here is, I show this to my students in the radiation and basic satellite meteorology subject. It is a table showing a particle radius on the y-axis and the wavelength on the x-axis, and it shows the kind of scattering that happens as you vary the wavelength of the light and the particle radius, the particles that are intercepting that radiation. And so what you'll notice is that that for visible light, and including cloud droplets, dust, smoke, and haze, you get this me scattering, which is affects all wavelength equally, and so you get white light scattered. Let's go on to the second part of this presentation, which is looking at the satellite data. Now, I couldn't resist, of course, on the Monday, or actually Tuesday, coming in and getting that information down. First, what I'd like to do, though, is just step back a little bit and show you this mean sea level pressure chart. It's overlain, the mean sea level pressure analysis is overlain onto an infrared satellite image over the Australian region. You can see the area of interest, Melbourne, in the light blue square there, a dotted square. You notice there are high pressure centers over the region. You have light surface winds as a consequence. There are coastal sea breezes may have an impact because there's very little cloud about, so good insulation. And you've seen it in the images. It was a blue sky, though it was kind of milky and murky and as you looked more toward the horizon. So, and then of course, under those conditions, fog and low cloud are a possibility also. What I decided to do then was to do an animation. And I don't know, can you see this animation properly? I'll let it play a couple of times. Please let me know, Ani, if you want to use a microphone, whether it's playing okay.
We can see that it's playing very well.
So thank you very much, Ani. So what we're seeing here is the area over Melbourne. Melbourne is circled in the white ellipse. You're having that transition from the night microphysics RGB, which is the colorful one at the start of the loop, into the true color RGB, which represents more like what an astronaut would see looking down. And there are a couple of points of interest. First of all, if you go to the night microphysics, you'll see these dark violet spots that are hotspots. And then if you see during the day, you'll start seeing the smoke coming out as you get the heating of the land and some thermals developing, and maybe as the burning activities becoming more busy as well. You'll notice too that there is a sort of appears to be a flow of low cloud, which has the aqua blue color in the night microphysics and has more a whitish color in the true color RGB. Then it seems to be advecting toward Melbourne from the west. And if you look really carefully toward the end of the loop, you might see some haze over the Melbourne area. Now, we'll look at that a little bit more closely in this animation. I've zoomed right into Melbourne, and you should be able to see the dissipation of the low cloud, and then this haze appears to move northwards in the direction of those black arrows, and maybe with a boundary kind of that has that shape that you see in the black line. If you can't see it very clearly, don't worry. There's some additional satellite imagery that'll show it more clearly. Notice too the fires that are over in the far right-hand side of this animation there. So what I've decided to do was also to look at the NASA Worldview web page for the Polar Orbiter satellite data. So the link is here. You basically choose, it has 20 years worth of data, so I had no problem in picking the 31st of March. I then zoomed into the area of interest, so I scroll with my mouse wheel there like so, and then I choose the satellite. And so this, I've actually flicking here between two satellites. One is the Aqua, the Aqua satellite with the MODIS instrument. The second one is the SUMI NPP satellite with the VIAS instrument. They're slightly different times. The SUMI NPP has the overpass earlier compared to the Aqua. And so you can see the shifting of that pollutant, the haze, northwards. And here I've put them side by side. So on the left-hand side, you have the two images corresponding from the Himawari satellite, corresponding roughly to those the time of the SUMI NPP on the top row, and on the bottom row to that of the Aqua MODIS. You'll notice that the polar orbiter does appear to show the haze somewhat better than the geostationary satellite Himawari 9, but by animating the imagery and maybe speeding it up, you can really pick that the movement of that smoke residue causing the haze far better than you could with polar orbiting satellite, of course. Just highlight the areas. Right, let's have a look at the soundings, the visibility, and the ceilometer observations. This is from Melbourne Tullamarine Airport sounding. And so the top left-hand side is during the night prior to the event. So this is what you might have seen in that night microphysics RGB. The bottom left-hand side is the morning of the event, just a little bit before I went for my walk, because it was a Sunday and I slept in a little bit. I didn't want to get up first thing in the morning. And then the third one is basically the following evening. So just some highlights. First of all, if you look at the sounding a little more carefully in the bottommost part near the surface, you'll notice that actually the temperature and dew point are together. So we have like a fog there very early in the morning at Melbourne Airport. We go into the morning, so after sunrise, 00 UTC, a couple of features of interest. There is a strong inversion at 950 hectopascals, potentially trapping the pollution below it. And there's also, again, some low cloud. You can see how temperature and dew point are touching aloft, but at the surface they're apart. So that is low cloud. You also notice the surface wind, it's a southerly advecting pollution northwards. Finally, as we look toward the next night, then you'll notice that the inversions weakened, because you no longer have that strong gradient in temperature and dew point temperature over shallow distance, and the low cloud would also have dissipated at this point because the temperature and dew point lines are apart. So let's have a look at the visibility reductions over Melbourne Airport at the time, and I've chosen 3 locations. So I've chosen Moorabbin Airport, I've chosen Melbourne Airport, that's Tullamarine Airport. So if you've visited Australia from overseas, it's very likely you've landed at Tullamarine Airport there. Notice it's the most northerly, the most inland. And then, of course, you also have Laverton Airport, which is, again, further to the south. Notice that for Moorabbin Airport, the reduced visibility that you can see in this graph outlined in red, where you have the horizontal visibility in the y-axis and the time in the x-axis. So from 21 UTC on the 30th through to 09 UTC of the 31st, the visibility reduction below 8 kilometers is for the longest time, and it also occurs the earliest. Whereas if you go over to Laverton Airport, that occurs, visibility reduction below 8 kilometers occurs somewhat later, and it lasts about this, looks like about the same time, around about 06 compared to Moorabbin. Look at Melbourne Airport, though. They had good visibility right up to 03, 04, at which point it dropped. So clearly that shows quite nicely that there was that advection of pollutant affecting the visibility in the vismeters at these stations, comparing across these stations. So the impact across on aviation operations, and this was something that our fire and air quality forecaster mentioned I should include some impact of this event. So first of all, of course, let's have a look at those 3 airports again and look at the highest alternate minima. And so that is 7,000 meters from Melbourne Airport, 8,000 meters for Laverton, and 6,000 meters for Moorabbin Airport. So if it ducks below that, you have the especie is generated and it's incorporated into the aerodrome forecasts. And so I want to give you an example from Moorabbin Airport. So this is the forecast from at 00 UTC. So mean conditions is a haze with a visibility of 5,000 meters. There's also broken low cloud with a base of 600 feet, but the visibility is expected to improve to 10 kilometers after 02 UTC. And you can see that there is an increase in visibility, so improvement of conditions, but then again it deteriorates. So TAF amendment was required. This one's showing, this is at 05, so sometime into it. Mean conditions with smoke with visibility 8,000 meters. And then periods varying between 30 and 60 minutes with the visibility to 5,000 meters, where the smoke is becoming thicker at times. And that's expected to last till 06. And at 06, the visibility indeed improved. Finally, I want to just show some further investigations over the broader Victorian region, just trying to tie it into when you see this haze.
Bodo, apologize for interrupting. You have another 5 minutes left.
How many?
5 minutes.
Oh, yes, that'll be fine. Thank you, Annie. Thank you for the warning. I won't have to speed up my talking. All right, so basically then try to link it into what happened more broadly. Again, we'll go back and look at the NASA Worldview resources, particularly the aerosol optical thickness and also the aerosol type. And then let's have a look at that. So in order to do that, we go back to our NASA Worldview webpage. You can see the link here. You click on Add Layers and a window like so comes up. You pick Air Quality and then you choose Aerosol Optical Depth. Now, aerosol optical depth is the optical depth due to extinction by the aerosol component of the atmosphere. And so just to give it a bit of meaning, you'll notice that an aerosol optical depth of 0 gives very good visibility, whereas if you get an aerosol optical depth close to 1, get a lot of scattering happening, and that's you really can't, radiation from a distance cannot really reach your eye, so you can't see the more distant mountains there in this image. This is the aerosol optical depth over Victoria and Melbourne, and this was during the day, so the Terra overpass a little earlier, and it's overlain by the Aqua overpass from 0426 UTC on the day. You'll notice the smoke from the fires with very, very high aerosol optical index, so going right up toward 1 and maybe even beyond that. But you'll also notice that haze, and again, the outlines of that indicate that the haze is coming from the west and is circulated in the Melbourne region there. Here we have a closer look at the aerosol optical depth just over Melbourne, and just picking 2 points. So one of the points here is between 0.335 and 0.0445. There, and the one that is haze free is down to 0.018 and 0.019 in terms of aerosol optical depth. Now, the other interesting, I guess, display that you can get with the NASA worldview is this the aerosol type. Again, you add layer, air quality, choose aerosol type, and you get this display. So now you have overlaid onto the satellite image, the true color and RGB underneath, these classification of the particulates in terms of smoke, mixed smoke, and other particulates, fine particulates, high altitude smoke, and dust. The reason why it's not a complete coverage is generally the aerosol optical depth is not captured very well, cannot be determined over very bright features such as clouds or ice or so. So it's one of the reasons why the data is missing. It's also a good idea to switch off the underlay to pick out, for example, the dust more clearly that otherwise might be obscured if I turn it back on again by the underlaying layer. Finally, finish off by looking at the importance of the particulate matter of size less than 2.5 microns or less. So here you have a schematic from Wikimedia, but it's from the Environmental Protection Agency, and it's showing a strand of hair. And then you see that within that you have the blue beads. Each one of those are 10 microns across, whereas a little red bead that sits within the blue bead, that's basically your 2.5 micron particulate matter. That's described as fine particles. These can penetrate deeply into the lung, irritate and corrode the alveolar wall, and consequently impair lung function. Now, I wasn't able to get any satellite data, and I'd be really keen if one of our experts, one of the experts in the audience, perhaps Dr. Nahas as well, could point me toward where I could find this PM205 from satellite data. But there was indeed a location here, Station Pier, that was measuring this PM 2.5, and it was in this publication by GHD, which is Station Pier Air Quality Monitoring Program. And you can see the output for the month of March here. You'll notice that as you move over toward the 31st, oh my goodness, it goes right up. And the main reason why you have these 3 blocks of very high values of particulate matter 2.5 microns is that because over the Easter season, if you have a high pressure system sitting over there, they do burning off in order to reduce the fuel, to control the look after the land. So this was actually the result of some very environmentally friendly activities, maybe making in other parts making the sky light up gloriously for our Easter Sunday, but maybe not so good for people who are maybe have asthma issues and so forth. So I'd like to summarize. I presented to you an Easter Sunday full of light that made it to Facebook as well. So haze can be beautiful sometimes, providing for those who have asthma, have a mask on, and so the viewing can be quite something. I've used geostationary and polar orbiting satellite to detect the extent of the haze, and surface and upper air observations were also used in the investigation. And I've examined appropriate satellite-derived products on the NASA Worldview webpage to interrogate the nature and origin of the haze, such as aerosol optical depth. Finally, surface observations of particulate matter less than 2.5 microns, the importance of measuring those, and it would be great to have those in satellite data also. Thank you.
Thank you, Bodo, for the very interesting presentation as well. So, I'm so happy to have you both here because, you know, it's a very precious things that we have two experts here sharing what you have in your side. So, now time for the question and answer. I saw in the chat there has been some questions for Alberth, and he already answered the questions. Yeah, so yeah, should I think I don't think that we need to read them all, right? So to save the time, so I hope that the answer is sufficient for the one who questioning that. So I would like to invite another question if you also have. I actually have one question for Mr. Bodo, but let us participants to ask first. So please, anyone who would like to ask any question to Mr. Bodo or Dr. Albert, please. Okay, if not, I have one question to Mr. Bodo about the like second last presentation about the NOAA's product, NASA products. So I saw that it has some interpretation of the what is that, the events, or like but is it from the NOAA, or is it or we have to interpret them by ourselves, like the low cloud, haze, smoke?
Oh, okay. Sorry, Annie. What I can do is I can just share the screen again and just bring up. Is this the slide that you referred to?
Yes, this one.
Okay. So
we can
yeah,
see there.
please.
Yeah, we can see some interpretation of the feature of the satellite.
Yeah.
The question is it I mean, is it coming from the NASA itself, or we can like interpret by ourselves?
Okay. So maybe the best way to. Sorry, please finish. I'm sorry.
And also, how is the accuracy?
Okay, so it's a good question. I don't know the accuracy itself offhand. I haven't used it that much, but what I can do is just show you how you can find out more information about about this. I think this will be really, really useful. So what I'm just doing now, I'm just calling up the web page. So here we go. And that way, I think this is a really good way to demonstrate it, because it's one thing putting it up on slides, but there's quite another thing me actually calling it up on the computer screen. So it's just going to come active now, and then to go through the, yes. So there's your page. So if we follow the instructions that in there earlier, right. So first, I'm just going to add a layer. And as soon as I do that, you see air quality. It also says aerosol type, which is, of course, what I've put in there. So when you put aerosol type like this, of course, you get many, many different choices. But what I'm going to do is to make it the same as what I've had in my display, which is the deep blue. So your deep blue display is very much focused on that very the shortest wavelength visible channel, but there are, of course, other techniques. But I can just go and use the NOAA and the SUMI NPP, because that's what we have here. And I can then throw it up like so. And once that's completed, I close this. And now over the whole world, you've got this classification and includes this little gap over Indonesia. So I might go back one day. Oh, no, not into the future. There we go. And now you can see how you have the different classifications. Now, if you're unsure about this, there is a little information button here. So if you do that, you start getting more information about how the cloud type, how they do the discrimination of that. And it includes some references there as well. So to answer your question, I'm not 100% sure about how this is obtained, the differentiation. I've only used it from time to time. And of course, if you go on to a particular location, as I'm doing there, then if you look at the aerosol type in that window over here, changes accordingly too. Does that make sense?
Yeah. Thank you so much.
But what I can do is certainly afterwards now I can do a little bit more investigation into this. And if I do come up with something, I'll certainly forward it to you.
Thank you. Thank you. Thank you, Bodo. And I also saw many questions as well to Mr. Albert, and I saw many question about the coding as well. It seems like it is one of the topic that we need to follow up perhaps in the future training or regional focus group meeting as well. And I certainly will share your both of your presentation in our learning management system, and also Mr. Bodo, I will share also your presentation to our aviation meteorological league in BMKG, because you also put that it's very operational, supporting operational things, especially for the aviation as well. So any other question from the participants?
Maybe I can say something about the code.
Yes, please.
Yep. Thank you. So the code. So the session is not about the code. That's what I realized. But I provide the codes that you can use, because probably that's the best way for you to utilize the satellite data. And I use this platform because I think this is the easiest way to run the code without having any particular machine or operating system. You can use this platform. One thing you need to do is you have to have the internet connection and also the Google account. And in addition to that, you also have to make the account for the NASA firm's website and the other one, Sentinel. Both are free. It's also straightforward. You can follow the instruction from the sites, and the code provides the very specific location, but you can actually change the location if you have some knowledge on the Python code. But we are happy to help you if you have any problem. You have my email from the presentation. Just feel free to contact me if you have any further questions.
Thank you, Albert, for the further information about the Google Collabs things. Yeah, I saw from the last meeting in OMSUC meeting, I saw many countries or members also requested, have the challenges in satellite data visualization. Perhaps this Google Collabs could also be one of the solutions. And Bodo, maybe next time we can think about this future training, further training about this data visualization. Okay, I saw now it's already 10. I'm sorry. What is the UTC? 3 UTC now. It's already 3 UTC now. So I thank you once again for our two most expert, I mean, two experts who already shared their knowledge, which is very important to us today. And also, I have to thank you all the participants for your for joining these important sessions. We really do hope that we can. I think next we will have Australian regional focus group meeting next month, right, Bodo?
Yeah, that's the planning is to conduct the next Australian VLab Centre of Excellence Regional Focus Group meeting during March. I've yet to
March.
determine
Okay.
when, or we've yet to determine when, but yep, it'd be great to have, how can I say, the Indonesian VLab Centre of Excellence members in the, and BMKG Indonesian colleagues in the audience for such an event. And yeah, certainly if are there any particular topics of interest or case studies, I'll be keen to hear from you.
Okay, so let us know if you have the dates, and then we will try to we will also share to our contact informations. So everyone, thank you very much once again. Hope to see you again in the next VLab, Australian or Indonesian VLabs. Thank you. Have a great day,
Okay.
everyone.
Bye.
Thank you all. Bye. Thanks, Bodo.
Bye.